What's up, Titans? This is Mr. Sturts. We're on lesson 5.4, solving special systems of linear equations. Okay, now think back to section 5.1 when we graphed to find solutions. Remember, the solution of a graph is where the two lines intersect. So in this section, we're going to focus on a few special solutions to these systems. Okay, this first one here where it says one solution, where the two lines intersect, that ordered pair was our answer. Okay, so maybe this was, I don't know, negative 2, 2. Okay, that could be our solution. There's one solution, that's our answer, that ordered pair. This middle one, if we have two lines that are parallel, remember parallel lines never intersect, so we're not ever going to get a solution. Those two lines go on forever, they never intersect, we get no solution. Our third and final special case is if we have the same exact line. If that line, we think about where that line intersects, two lines on top of each other, they intersect at every single point on that line. And lines go on in each direction forever, so we're going to have infinitely many solutions. If you run into something like, y equals 3x plus 5, and the second one you get y equals 3x plus 5, if you graph that, you know those lines are going to fall directly on top of each other. If that's the case, we have infinitely many solutions. Alright, let's try one here. Solve this system. We're going to use by graphing here. So this first one, 1 is our y-intercept, so we're going to plot a point on 1. We're going to go up to right 1, up to right 1. Our slope right here is 2. Okay, and we have this line right here through the points. And the second line, negative 5 bar y-intercept, so we're going down 1, 2, 3, 4, 5, plot a point. Our slope again is 2, up to right 1, up to right 1, up to right 1. Okay, notice these lines, if we were to draw our line through the points, these lines are parallel. Another way we can see that our lines are parallel, they have the same slope. Parallel lines never intersect, so we are going to have no solution. Those lines never intersect. Some of you can look at those equations and tell right away that they're parallel, because we have the same slope. We just need to make sure our y-intercepts are different. If the y-intercepts were the same, those would be the same exact line. So we would have infinitely many solutions. Alright, let's go on to this one. Again, we're going to graph it. We need to solve this system. Let's see, we need to get y by itself. So let's work with that first equation here. So y equals, we're going to move our 2x to the other side, add 2x. When we do that, we're left with 2x plus 3. That's our first equation. Now let's rewrite our second one. I'm going to rewrite it down here. Negative 4x plus 2y equals 6. Okay, if we were to rewrite this, get it in y equals mx plus b, we have to add 4x first. So we're left with 2y equals 4x plus 6. Get y by itself, divide by 2 on everything. So we're left with y equals 2x plus 3. Okay, look at these two lines. This equation and this equation are the exact same. So what we just talked about was if we were to graph these 1, 2, 3 up to right 1, you really don't even need to graph these. Hopefully we can tell right away that those are going to be the same exact line. They lie right on top of each other. They're the same equation. So when we get that, we have infinitely many solutions. Okay, infinitely many solutions. Same line, infinitely many solutions. Parallel lines that never intersect, no solution. Alright, let's look at these. We don't always need to solve by graphing. Okay, maybe on number 1 here, it'd be easier in this case to solve by, let's say we're going to do elimination. Okay, if we think elimination, we need to get one of our variables to drop out. Let's try to get our x's to drop out. So we have a positive 2 down there. We need to multiply the top by a negative 2. Distribute to everything. So if we rewrite that top equation, we now have a negative 2x minus 2y equals a negative 6. Let's go ahead and rewrite this equation. Let's bring it down. 2x plus 2y equals 6. Now look what we get. We get our x's to cancel out. Negative 2x and a positive 2x is 0. Negative 2y and a positive 2y is 0. Negative 6 and 6 is 0. Well, 0 equals 0. That's true. Okay, if you get two numbers that equal each other in a true statement, that is going to be infinitely many solutions. Okay, they equal each other. If we had 5 equals 5, that would be infinitely many solutions. If we had 10 equals 10, same thing. If you get a true statement, infinitely many solutions. All right, let's look at number 2. You can also solve these by substitution. I would probably pick substitution here because y is already by itself. Our variables aren't lined up, so elimination wouldn't be very easy. They're not both in slope-intercept form, so we probably wouldn't graph them. Let's use substitution. So let's take our negative x plus 3 and plug it right in for y. So we have 2x. We're rewriting the second equation. 2 times y, which is negative x plus 3, equals 4. Distribute. 2x minus 2x. 2 times 3 is 6 equals 4. 2x and a minus 2x, if we subtract those, we're left with 0. 0 plus 6 is 4. 6 equals 4. Well, that's not true. 6 does not equal 4. If we get a false statement like 6 equals 4, we have no solution. No solution. If we get 6 equals 4, that's not true. No solution. Okay, that'd be like graphing parallel lines. If we were to graph those, put them both in slope-intercept form, we would get 2 parallel lines that never intersected. No solution. Okay, last example here. A little word problem, application problem. We think of the perimeter of a trapezoidal piece of land. Okay, trapezoid, this top picture here, is 48 kilometers. The perimeter of a rectangular piece of land is 144 kilometers. We need to write and solve a system of linear equations to find x and y. So let's focus on our trapezoid here. We're working with perimeter, so that means we need to add up all of our sides. Okay, our perimeter, if we have 2x and a 4x, well, 2x plus 4x is 6x. If we add up our y's, 6y and 6y, we get a 12y. And we know that is equal to, they said the perimeter of that trapezoid is 48 kilometers. Now, if we look at the rectangle, add up our x's, let's line them up. We have 18x, 9x plus 9x. Then our y's, 18 plus 18 is 36y. Now, they said that's equal to 144 kilometers. Okay, now we need to do the math here. Let's see, what would be the easiest? We obviously wouldn't graph it with those big of numbers. We probably wouldn't use substitution because it's tough to get x and y by itself. Let's use elimination. We need to eliminate one of the variables. Let's work with this top one. What can we multiply up here to get our x's to eliminate? We have an 18 down there. We need a positive 18 up top. So let's multiply the whole top equation by a negative 3. Distribute to everything. So let's rewrite the top equation. Negative 3 times 6 is a negative 18x. Negative 3 times 12 is a negative 36y. Negative 3 times 48, that's actually a negative 144. All right, now add straight down. Do the math. Negative 18 and a positive 18, well, that's 0. 36 and a negative 36, well, that's 0. 144 and a negative 144, that's also 0. Remember when we said 0 equals 0? That's a true statement. We are going to have infinitely many solutions. What that means is you can plug in any number for x and y, and these are always going to be true. Okay, it's always going to be a trapezoid, always will be a rectangle. Infinitely many solutions. True statement. All right, now that you're done, do a couple of these practice problems out of your student journal. Turn to page 150. Do numbers 1, 4, and 7, and we'll go over them in class tomorrow. Thanks for watching. Have a great rest of your night.